Hi, my name is Michael Nadeau, and this is my ISA 4220 presentation on operating systems and firewalls. This slide is a quick overview about what I'm going to be covering in the presentation today. First of all, we're going to have a technical discussion on the operating systems, and then I'm going to go over the best practices for Windows Server 2012 R2 and CentOS. After that, we're going to have another discussion about firewalls, and then we're going to go over the best practices of Windows Firewall and IP tables. Operating systems are at the core of every electronic device we use today. That cannot be more of the case than with servers, phones, and computers. Today, the most popular operating system is Microsoft Windows. The current operating system version Microsoft offers for PC users is Windows 10, and the current operating system that they offer for servers is Windows Server 2012 R2. Windows has been around since 1975, and since then they have released multiple operating systems, from the MS-DOS to Windows 98. Windows has always seemed to be the most popular OS for PC users. Unix, on the other hand, is not too popular among average users, but for web server providers, Unix-based system is the way to go. There are many different types of Unix-based operating systems that are available to the public today. The reason is that Unix's software was open source, meaning it was free and available to anyone. But some people from around the world decided to get together and develop their own operating systems with Unix at the core. The creation of popular operating systems like Linux, BSD, and even Mac OS X were possible from the generosity of the Unix developers and the sharing of their software. So as I discussed in the previous slide, I went over the different operating systems. There's quite a few. What I want to focus in this presentation on is the similarities between the operating systems. In the bullets I have right here, all of them are similar except for the interface to the file system. It's different between Windows and Unix based systems. As you know, every time you boot up a computer, the first process that is run is the operating system. And yes, the operating system is a process. But other than that, I'm going to talk about how the operating system allocates memories to processes. I'm going to talk about how the operating system schedules the process to run on the CPU cores, and then I'll talk about how the operating system controls the hardware processes, and then how the operating system manages the I/O devices. This slide will cover the underlying actions the operating system takes to write a process's logical data to physical memory. When the process data is wanting to be stored in physical memory, such as RAM for execution, the process will invoke the OS with a specific system call. The operating system begins to analyze the process memory space and monitors the size of each part of the processor's memory, or process's memory. The process's memory space is occupied by three separate sections of memory called the stack space, heap space, and the text space. The operating system will try and associate this memory with a specific table that is managed only by the operating system and is stored in the registry. If a location has not been associated with the process, the operating system will start transferring the logical memory to physical memory. The operating system will annotate in a process memory table on the memory location at which it had placed the processes. When the process needs to access its memory, the OS will refer to that process memory table and analyze if that process has access to that memory. The swap feature of the operating system is a very unique feature that allows process memory to be stored on a storage device other than RAM. And then when the process is called, the operating system will swap the memory from the storage device to the RAM. This ensures the RAMs won't be occupied with too much memory. An important feature of an operating system is the ability to run multiple processes at the same time. Without those processes interfering with each other, the issue is that the essential processor unit can only handle one process at a time. To utilize this obstacle, an operating system has its own process it runs called a scheduler. The scheduler is an important part to the ability of the operating system to provide the execution of multiple processes at the same time. The scheduler prioritizes each process in the order to be executed on the CPU. Even the scheduler, being that it is an operating system process, also needs to be processed by the CPU. Today, CPUs have multiple cores to meet the high demand of concurrent processes. It is the job of the scheduler to organize the resources of each core so that multiple processes can run at the same time. With multiple cores, the scheduler can alter processes back and forth between each core for seamless performance without process interruption. A process task is either ended by timing out or getting stopped by an interrupt handler. The interrupt handler are commands from the other processes that need access to the CPU. Interrupts are very important. If interrupts did not occur, the running process would never end and consume the entire CPU resource. Today, CPUs come with a built-in clock device that sends interrupts constantly at very high speeds. Some clock speeds can invoke 15 million interrupts every second. The clock device ensures that the schedule will be invoked and allows to change the process multiple times per second. Another feature of the operating system and what it provides the system that it's on is the management of all the I/O devices, which pretty much mean the hardware devices, the input and output. The first component of managing these devices is the device driver. The device driver is used to translate bits to programming language for a piece of hardware. Without the driver, a piece of hardware would be unable to function. In most cases, a common driver will be installed for a common piece of hardware. For example, a mouse would have a common mouse driver that would be capable with most other mice. The drivers are usually pre-installed on an allocated kernel. For more advanced drivers, such as video cards, the technology and the way the card talks to the processor is different than most other video cards because of the changing technologies. So the driver would need to be installed to the kernel. This will ensure that the hard drive device will be able to communicate through the OS on the certain processes that are invoked by the hardware. When a hardware system call is generated, it is usually set in a high priority block to take precedence over other system calls. This is just one of the small tasks that the OS performs. Operating systems are at the core of every electronic device we use today. That cannot be more of the case than with servers, phones, and computers. Today, the most popular operating system is Microsoft Windows. The current operating system version Microsoft offers for PC users is Windows 10, and the current operating system that they offer for servers is Windows Server 2012 R2. Windows has been around since 1975, and since then they have released multiple operating systems, from the MS-DOS to Windows 98. Windows has always seemed to be the most popular OS for PC users. Unix, on the other hand, is not too popular among average users, but for web server providers, Unix-based system is the way to go. There are many different types of Unix-based operating systems that are available to the public today. The reason is that Unix's software was open source, meaning it was free and available to anyone. But some people from around the world decided to get together and develop their own operating systems with Unix at the core. The creation of popular operating systems like Linux, BSD, and even Mac OS X were possible from the generosity of the Unix developers and the sharing of their software. In this slide, we'll talk about CentOS's best practices. First step to best practice is to install helpful packages. Packages such as TCP dump, MTR, ZSH, Perl, and Legrotet. This will help you with networking issues if you ever get stuck. Next is apply automatic updates or automatic yum updates. This is very important in case something comes out. You'll be the first one to have it. Next is password and OS policies. Good or best practice for password policies. Expire the passwords after 180 days, and also passwords may only be changed once a day. Next is set the OS policies, or the operating system policies. This one should be set to where idles will get disconnected to after about 15 minutes. Next is you want to install IP tables. We'll discuss the configurations for that later on. Next is you want to install malware detecting software. The different kinds are DDoS Deflate, Check Rootkit, and Rootkit Hunter. And then Linux Socket Monitor. These will all help you detect unwanted software. Firewalls are extremely important for the safety of networks and personal computers today. It controls what comes in and outside your network, or what comes in and outside of your node, depending if you had a personal firewall or hardware firewall for your network. The firewalls are usually placed on the outside of the network, touching the internet. Not only that, it is recommended that you have multiple firewalls and you can segment your environment. Reason being is if someone penetrates the first firewall, you still have that extra protection. The different types of firewalls that I'll be talking about today are packet filtering firewalls, stateful inspection firewalls, application firewalls, circuit gateway firewalls, and guard firewalls. I'm also going to talk about the network layers, and we'll get to this right after. To understand how firewalls inspect data packets, we first need to know how the data packets are put together. And the OSI model is kind of a reference to show you how the packets are put together and at which rules they are sent over the network. So at the bottom you see we have the physical layer. So if you're receiving a message or a data packet over the network, this is the first layer it hit. Physical layer is like the optical cords or your Ethernet cords. They're your physical that you can touch. So a protocol or standard for one of them would be the type of connector that you would use. Then I'll go on to frames, which checks the MAC address and the LLC, and so on and so on. Well, the firewalls, they only really care about, well, most of the firewalls only really care about the transport layer and the network layer. The network layer has the physical address or the logical address of either the source or destination. So it is able to tell you where the message actually came from. And it also has a path determination, meaning the ports. You can either block or deny or allow different ports or IP addresses. The next is the transport layer. This layer ensures that the data that was sent was either reliable or unreliable by checking for missing packets. It also has TCP synchronization in case a packet is dropped due to interference. So when we go on to discuss the different types of firewalls, please be aware of what network layer and what information each firewall is checking for. Another feature of the operating system and what it provides the system that it's on is the management of all the I/O devices, which pretty much mean the hardware devices, the input and output. The first component of managing these devices is the device driver. The device driver is used to translate bits to programming language for a piece of hardware. Without the driver, a piece of hardware would be unable to function. In most cases, a common driver will be installed for a common piece of hardware. For example, a mouse would have a common mouse driver that would be capable with most other mice. The drivers are usually pre-installed on an allocated kernel. For more advanced drivers, such as video cards, the technology and the way the card talks to the processor is different than most other video cards because of the changing technologies. So the driver would need to be installed to the kernel. This will ensure that the hard drive device will be able to communicate through the OS on the certain processes that are invoked by the hardware. When a hardware system call is generated, it is usually set in a high priority block to take precedence over other system calls. This is just one of the small tasks that the OS performs. So with the previous firewall, it was unable to easily configure a connection. The answer to that problem was with the stateful inspection firewall. Basically, the stateful inspection firewall is a packet filtering firewall, besides the fact that it keeps memory of recent connections. For example, when you do connect to that, let's say that web server we discussed earlier, your connection will go into what is called the stateful packet inspection table. So when you send a sync request or TCP request to the web server and it responds with a sync ACK, essentially the SPI table will take over and allow that connection, and then when the ACK is sent from the back to the web server, it will allow that connection, and then the connection will be considered as established. Once the TCP connection is over, it will be listed as terminated. I'm sorry, I meant closed. The connection will be listed as closed, and then if the server decided to try to communicate back to the user, it will block it. The next firewall is called the application proxy, which is also known as the bashing host. This application proxy filters the content that is on the application layer. How this works is, let's say a host computer wants to access a web server and communicate with the web server. Well, the application proxy will have to have a web server installed on it, a web server application installed on it with a browser, and then when the host sends a request, it will actually go to application firewall. The application firewall will break it down to the application layer, inspect the application layer content, see if it's okay or not. It will either allow or deny. If it allows, it goes to the web server. Web server will process it and send it back. It then will hit the application proxy again, and then the application proxy will break down the web server's content and evaluate it and either accept or deny it, and then set it to the host computer. It is almost like the application proxy is a liaison for the host computer to the outside network. The circuit level gateway. This gateway is a pretty simple firewall. It is used to create secure connections. You'll find a target host or target destination, and a tunnel is going to be set up between that destination and the circuit level gateway. This is also called a VPN. So what happens is, if let's say the destination wanted to send us information and it was trusted, it would send it across the tunnel, it would encrypt it. Their circuit level gateway will verify that it is going to our circuit level gateway or trusted gateway. It will be sent over, encrypted, over the tunnel, received by our circuit level gateway. The header of the packet is torn apart, verified that it is the secure location, and then it is passed by the circuit level gateway to a decryption device, and then straight into the network. Now, let's say if it was not a trusted gateway or connection, the gateway would just deny it and then send it on to the firewall to be inspected more. The final firewall that we are going to discuss is the personal firewall. The personal firewall is almost like all the other firewalls, besides the fact that it's software based. Back in the day, users did not have a protection, average users did not have a protection against the outside internet. They just could not afford to buy a piece of hardware to protect themselves. So a software-based firewall was developed. This firewall works on the network level. This is a very, very effective tool if you know how to configure it correctly. Alright, now we're talking about Windows Firewall best practices. Now the first best practice that should be enabled is through IPsec. There's a setting that is able to enable encryption between non-domain and domain users. You can also have it where it denies all connections too. You also want to set the inbound rules and the outbound rules, and the best way to start off is by a default deny, and then build your rules and policies from there. Next is the management of the firewall. You can do this by setting up group policy to control the configuration of the firewall. But one of the easiest ways that you can do this is with firewall with advanced security snap-in. And you can create a role to export it and import it to the group policy management editor. Then with this feature, you can use group policy to push it to the administrators that need to control the Windows firewall. So through group policy, you can touch all those machines without having to actually go there and make the configurations. The next best practice is logging. By default, Windows Firewall actually has this turned off, but it is good practice to turn this on, because if you do have an issue with your firewall, logging makes it easier to pinpoint the location of the error and you'll be able to fix it. Moving on to the IP-Fire best practice rules, firewall rules. The first one is to set the default policy to accept. The reason for this is because if you do set the default policy to drop, pretty much all your connections will be severed. Nothing could get through to your network. Next is a best practice, just to make sure that you don't block the local host. A lot of local hosts, a lot of applications use the local host as an interface. So make sure you do not block the local host. The way you manage your IP tables will determine how easy it is to go back and actually troubleshoot or remove or understand what change you actually made. So if you actually have a really complicated rule, make sure you do it in separate chains so it's easily manageable when you come back to it. When you test the rule, you should use the reject instead of drop. The reason being is if you do a test and the setting is set to drop, you'll never know if it actually worked or not. If you get a reject, you can actually go in and check and see that it did reject the TCP connection. The next is triple check your inputs chains. Being at the firewall, you can cut communications easy. So every time you do input a chain, make sure you review over and over and over to make sure it is the correct. If you do write a rule, make sure you comment on what it actually does and what it is for. So if the administrator comes in, the administrator can verify if the rule is applicable or not. And the last thing is save those configurations in case of something happens. Well, I hope you enjoyed this presentation, and I hope you have a good day. Thank you.